Okay, so this is the Module 3 review. For those of you at home, there is a worksheet that the review is, that I'm getting these problems from, okay? And the answers are on the problems. The answers are on the review sheet. Let me try to shut some stuff down so there's not so much lag time. It looks like this, but I'm going to be doing all of the work on a separate sheet of paper, and I would like you to also do the work on a separate sheet of paper. There's just not enough room on this review to do your work. And of course, no work, no credit. I'm giving you the answers. You got to prove it. Okay? So, yes. Well, I would like it stapled to it, so that way if you need it in the future, like if we have a midterm exam or whatever, you'll have it with you. And so, yeah, we'll just staple it to the front of all your papers, okay? Okay, so the first section, 1 through 13, the directions ask you to solve by factoring. So this whole test, the whole test is only on solving quadratics. There's 3 methods: factoring, quadratic formula, and completing a square. The first whole section, we're doing factoring for the whole thing. If you were not here for that lesson, I posted a video on Schoology. You can also go to YouTube and just search solve equations by factoring. You'll find a whole bunch of videos. There's different ways to do it. There's, I don't know, 5 or 6 methods that I know of how to solve quadratic equations, okay? You've learned how to do it before. Your teacher may have taught you a different way. You can use that way if you remember how to do it and you can do it correctly. I don't care. Just either use my method or learn your own method by watching other videos, or maybe you already know. But factoring, big deal in Algebra 2 and all future math classes. Yes, so. There are going to be different sections like this. So, you know, so don't just say, well, I'm just going to learn how to factoring, because just how to factor because it's multiple choice, I can get the right answer. Well, not everything's factorable, right? So say I do tell you to solve by completing the square, but you're like, I'm going to use quadratic formula. If it's multiple choice, I don't care, whatever, as long as you get the right answer. But if it's not multiple choice and I say solve by completing the square, I want to see your work, and you better use solve by completing the square. Okay? And hint, hint, if you're here for the original test, it's all going to be multiple choice. However, if you have to do a retake, or if you're absent and it's unexcused on test day, that's not going to be multiple choice. Okay, and so you will have to do whatever method that I say on the test. Does that make sense? Okay, so let's do number 1. Solve by factoring. So we have x squared plus 4x equals 12. X squared plus 4x equals 12. So remember, when you are using the method of factoring, the first thing you want to do, and you may need to go back and review your notes. Can you use notes on your test? No, you cannot use your notes on your test. When you're solving by factoring, you want to make sure that your equation is set equal to 0 and in standard form. Sometimes it will be already, sometimes it will not, okay? This one wasn't. So to get it set equal to 0, I wanted to move that left over to the right side. So 12 minus 12 is 0. On the left side, do we have any there's 3 terms. Are any of them like terms? No. So we need to put it in standard form. What's my first term? X squared, then 4x, and then negative 12. Don't start trying to determine A, B, and C and all that stuff until it's set equal to 0. All right, next thing we want to do is, if there's a greatest common factor, we want to factor it out. Does this problem have a greatest common factor? No. If it did, we would factor it out. So now we determine A, B, and C. What is A equal to? 1, that's the coefficient of your quadratic term, right? What is B equal to? Positive 4, that's the coefficient of your linear term. And what is C equal to? Negative 12. So we're going to make our t-chart. We need two numbers that multiply together to give us a times c. What is a times c in this case? -12. And on the right side, we want those same two numbers to add together to give us b. And in this case, b is +4. Any ideas? All right, let's see. Well, we haven't solved it yet. You'll see what I'm talking about. So -2 times +6 does give me -12, and -2 plus 6 does give me +4. So that works, right? The -2 and the +6. So we make two sets of parentheses. Whatever variable that's being used in the problem is the first term in each set, x. The numbers from the t-chart, the numbers that you multiplied on the left side and added on the right side, those are the numbers that are the second term in each set. Then, remember, this is called the divide and slide method. You need to divide each of those numbers that you took out of the t-chart by whatever a is. But when a is 1, if you divide these numbers by 1, does that change anything? No, so if a is 1, then that's not necessary. You don't have to do that because -2 divided by 1 is still -2, and 6 divided by 1 is still 6, okay? So it's not necessary, but if a is any number other than 1, you must do that. So I have completely factored. I'm factored, I'm done. But the direction said solve each equation by factoring. Have I solved? No. What do I do to solve? Set each factor equal to 0, exactly. To solve, set each factor equal to 0 and solve for the variable. So I've got two factors. X minus 2 is a factor, x plus 6 is a factor. Set x minus 2 equal to 0. I'm going to set x plus 6 equal to 0. And then I'll solve them separately. So for the x minus 2, I'm going to add 2 to both sides. X equals +2. Do you see, Toby, how it's +2? And on the other one, you subtract 6 from both sides, and x equals -6. I have two solutions, +2 and -6. If you look at your answer sheet, it says your solutions are +2 and -6. We are solving quadratics. You're going to have two answers and only two answers for every single problem. A quadratic means 2 degrees. If you have 2 degrees, you're going to have two answers, either two real answers or two imaginary answers. Coolio? Any questions on that one? Okay, let's do number 6. So, I mean, mine is all nice and neat. Notice I circled my number 1. I got my number 1 circled. So it's okay, these problems that we're doing together, if they're out of order, just make sure everything's numbered and everything's neat. So number 6 is 2n squared minus 6 equals n. Same method, solve by factoring. I gotta add what? Let's subtract n. We want, because my first term's a quadratic and it's positive, we want it to stay a quadratic and positive. So let's bring this n over to the left. So yes, we will subtract n from both sides. So on the right side, n minus n is 0. On the left side, in standard form, what would my first term be? 2n squared minus n minus 6. A lot of kids make the mistake and they'll just say 2n squared minus 6 minus n because that's the order that they see it in. That's not standard form. Constant always comes last, so be careful about that. When students mess up on this and they don't understand why, that's always what it is. They just didn't put it in standard form. All right, so once it's set equal to 0 and in standard form, we factor out a greatest common factor if there is one. Do we have a GCF? Will 2 divide into negative 1n evenly? No, it's got to divide into all 3 terms, not just 2 of the 3, okay? So there's not one. So what is A equal to? What is B equal to? And what is C equal to? Negative 6. So we're going to make our little T-chart. On the left side, we need 2 numbers that multiply together to give us A times C. What is A times C? Negative 12. And on the right side, we want 2 numbers that add together to give us B. What is B? Negative 1. 3 times negative 4, I heard. Let's see. 3 times negative 4 does equal negative 12. 3 plus negative 4 does equal negative 1. Boom. It worked for both sides. 2 numbers that multiply to get negative 12. We want those same 2 numbers to add to get negative 1. That's what works. A positive 3 and a negative 4. So once we know the numbers we're going to use, we make our 2 sets of parentheses, and we're going to put our factors in those parentheses. What is the variable being used in this example? N. Almost went with it. So that's the first term in each set, always. The second term in each set comes from the numbers that we got in the T-chart. So on both sides, the positive 3 and the negative 4 worked. It does not matter which parentheses gets the positive 3 and which parentheses gets the negative 4. Now on the last one, when we did the divide and slide part, by A was 1, it didn't change anything. But this time, A is a number other than 1. So it will change things, okay? So what I do, this is called the divide and slide method. I'm going to try to divide those numbers that I got from the T-chart. If they divide evenly, I'll divide. If they don't divide evenly, I'm going to slide. If I slide, I got to reduce before I slide if possible. So let's look at 3 halves. Does 3 divide by 2 evenly? No, so it's going to be a slide. Well, can I reduce 3 halves? Not divide it, reduce it. No, but if I could, that's not reduced, that's just converting to a decimal. Reduced is like, is there a number that divides into 3 and 2 evenly besides 1? No. Okay, so I can't reduce, but if I could, I would. So this is called a slide. So what you do, you take the denominator and you slide it on up and put it in front of whatever your variable is. It becomes the coefficient. So we have 2 goes in front of n, so 2n. Bring down your plus 3. So we just moved the denominator and we just brought down the numerator, okay? In my other parentheses, does negative 4 divide by 2 evenly? So I'm going to divide. I either divide or I slide. Sometimes you have 2 slides, sometimes you have 2 divides. Usually you have 1 of each. So that would be n, what's negative 4 divided by positive 2? Minus 2. Okay. So those are my factors. 2n plus 3 is a factor, n minus 2 is a factor. If I multiply those together, I'll end up with 2n squared minus n minus 6. Okay? But the directions didn't ask me to factor. It said to solve by factoring. So we're factoring to help us solve. So once I have my factors, what do I do? Set each factor equal to 0. Two n plus 3 equals 0. What do I do? Subtract the 3 from both sides. So 2n equals negative 3. Then what? 5 by 2. And n equals negative 3/2. If you put negative 1.5, that's okay. But your the test is going to show you the answer just like it does on the answer sheet, because I use this same software to write the test. So it's not going to change it to a decimal. It's not going to change it to a mixed number. It's going to leave it as negative 3/2. Your other equation, we're going to add 2 to both sides. So n equals positive 2. Positive 2 and negative 3/2 are your answer. And that matches what our worksheet said, where I told you what the answers were. Right on? Questions on that one? Look at number 10. I'm not going to do number 10 with you. But on number 10, when you subtract 1 from both sides, aren't you going to have 4x squared minus 1 equals 0? Does it have a greatest common factor? No. What is A? What is B? 0. There's not a linear term, so B is 0. What is C? Very good. So just be careful about that. A lot of people say, well, this is A and this is B because there's only 2 terms, so it's A and B. No, it's not. You got to pay attention. Is it the linear term? Is it the constant? What is it? Also, that's a difference of 2 squares, a perfect square minus a perfect square. So you can factor that using a shortcut, right? Or you can do T-chart divide and slide, but I'm not doing that one. I will do, let's do number 11. Oh, that's weird. Not on purpose. 11 and 12 have the same answer, but well, almost the same answer. And 3/2 is popular on this sheet. All right, number 11, it's just coincidental. It doesn't mean anything. 6a squared equals 18 plus 3a. Now, we did this in our notes. And I know it's easier to just subtract 6a squared from both sides. It's easier. Right, but you don't want your leading coefficient to be negative. You want it to stay positive. So even though it's an extra step, we're going to move the 18 over to the left and the 3a over to the left. So if I want to move plus 18 to the left side, I have to add I have to subtract 18. I can't just put an 18 on the left. And I'm going to do this at the same time. Instead of plus 3a, I want to move the whole term. So I will subtract 3a. So on the right side, I have 0. On the left side, I have 3 terms, 6a squared minus 18 minus 3a. Are any of them like terms? What? It's negative 3a. No, I said like terms. No like terms, not GCF, like terms. Like, am I going to combine any of these when I write it in standard form? No, okay. So what's our first term? 6a squared, and then, there we go. Now, is there a greatest common factor? Yeah, what is it? Okay, I have to factor out a 3. So I just write a 3 outside parentheses and make big parentheses. It doesn't go away. To figure out what's left inside the parentheses, I divide each term by 3. What is 6a squared divided by 3? 2a squared. What's negative 3a divided by 3? Negative a. What's negative 18 divided by 3? Negative 6. So now when I determine a, b, and c, we're not using the 6a squared minus 3a minus 18 before. We're not factoring that now. Now we're factoring the quadratic that's inside the parentheses. It's still a quadratic because a's highest exponent is a 2. Sometimes that changes, but it's still a quadratic. So what is a equal to? What is b equal to? Not 0, negative 1. And what is c equal to? Negative 6. So I've got 2 numbers that multiply together to give me a times c, which a times c is negative 12. Multiply, multiply, On the right side, you want two numbers that add to give you b, and b is -1. Okay? 3 times -4 is -12. 3 plus -4 is -1. Cool. So that worked. A +3 and a -4 gave me what I needed on both sides of the equation. So make my parentheses, but don't forget that 3. It's a factor. Just bring it down. Okay? So, but now I'm factoring the quadratic into 2 factors. So you make 2 sets of parentheses. What's the variable they're using in this problem? A. So that's going to be the first term in each set. The second term in each set comes from the T-chart. Which is a +3 and a -4. All right. Will we need to divide and slide on this one? Yeah, because A, and don't use your original A. We're not factoring the original problem. We're factoring 2a squared minus a minus 6. So use the A from the T-chart. You don't factor the GCF by A, only the numbers that came from the T-chart. Okay? So that 3 does not divide and slide. Just bring it down. A plus 3/2, divide or slide? Slide, because 3 doesn't divide by 2 evenly. Can we reduce 3 over 2? No. So the 2 slides up in front of the A to make 2a, and then you just bring down the +3. How about a minus 4/2, divide or slide? Divide, because it divides evenly. What is -4 divided by 2? So that becomes a minus 2. Now we factored. I have 3 factors, but I told you quadratics only give you 2 solutions and only 2 solutions, but I have 3 factors. But the 3, when I set it equal to 0, can 3 equal 0? No. So 3 is a factor, but it's not a solution. Okay? If that GCF was a variable, say it was a, and I set a equal to 0, a variable can equal 0. Remember, your solutions tell you where the graph crosses the x-axis, and it can cross at 0, okay? But 3 equals 0 is not a solution. You're going to get your solutions only from the factors that had a variable in them. So you'll get your solutions from 2a plus 3 and from a minus 2. So I'm just going to solve both of those for a. Y'all don't need me for this. Another solution of -3/2. Make sure your sign is what it's supposed to be. And your other solution is a equals +2. Yay. All right, so now factoring. Again, if you need more examples of factoring, watch the video on Schoology. We do a whole bunch of them on Schoology. So 14 through 19, you're supposed to solve using the quadratic formula. All right, I'll do 14 with you. So we have 7m squared equals 20. This is the quadratic formula. Quadratic formula, you still want to get set equal to 0 and in standard form, just like factoring, okay? So if I want to get this set equal to 0, what would I do? Subtract 20 from both sides. So I have 7m squared minus 20 equals 0. When you're using the quadratic formula, if there's a greatest common factor, you just leave it right where it is, okay? You don't need to factor it out. You still will need to determine A, B, and C. So what is A equal to? What is B equal to? 0. What is C equal to? Negative 20. And we're going to substitute that into the quadratic formula. X equals negative B plus or minus square root B squared minus 4AC all over 2A. Yeah. I'm not giving you the quadratic formula on your test. You need to have it memorized. I'm not giving it to you. Learn that song. So I'm looking for B, and I'm going to substitute in these values for A, B, and C. Okay? So X equals negative B. Well, B is 0. Can you have a negative 0? No, so you just put 0 plus or minus the square root of whatever B is, square it. Well, B is 0 minus 4 times A times C. So 4 times 7 times negative 20. All over 2 times 7. So X equals 0 plus or minus the square root. 0 squared is 0. And remember, I told you, do the minus 4AC all together. Is it? I believe you. I'm just going to check it out. Okay. So negative 4 times 7 is negative 28. And negative 28 times negative 20 is 560, giant number. And it's positive, right? Negative times a positive times a negative became a positive 560 all over 14. Okay, do we need the 0 in front of the plus or minus? No, so that's going to be X equals positive or negative the square root of 560 quantity divided by 14. Can I divide 560 by 14? If it was possible, could you? It's not 560, it's the square root of 560. Okay, you can't do that. The 14 is not under the radical, the 560 is. But look at your answer sheet. This answer is not on the answer sheet. Why do you think that is? Yeah, the radical, I'm going to bring it up here. 560 is probably not a perfect square. Let's check it. 560, hit the square root button. So if it's a decimal, we know it's not a perfect square. Yeah. You're wrong. It's not a perfect square, okay, but that does not mean that it can't be factored. It's a giant number, right? I taught you how to factor or how to simplify radicals. If you were not here for that, I also posted a whole entire video on simplifying radicals. You need to watch it. So I'm going to figure out, are there any perfect squares in 560? And if you have more than one perfect square, like what is the largest perfect square factor? So to do that, I do a factor tree. And you may start with different factors than I do. That's okay. Usually when I see numbers even, I'm going to figure out, I'm going to divide by 2 and get 280. So if 560 divided by 2 is 280, that means 2 times 280 are factors. 2 is prime. 280, divide that by 2, 140. So I'm going to break that down to 2 times 140. Hold up now. 2 is prime. 140 is 2 times 70. 2 is prime. Now 70 does not divide by, or 70 divides by 2, what am I talking about? 70 divides by 2, 2 times 35. Now, could we use different factors? Could I use 10 and 7? Yeah. We're going to get the same prime factors in the end. What's the factors of 35? 7 and 5. 5's prime, 7's prime. So write out all your prime factors. I have 1, 2, 3, 4 2's, a 5 and a 7. So are we going to have a perfect square? Yeah, you need a pair of the same number to get a perfect square. So we know we have a perfect square of 4. Well, look, there's another pair of 2's. We have another perfect square of 4. 5 and 7 aren't pairs, but I just multiply them together. They don't give me a perfect square, okay? And I told you when you multiply a perfect square times a perfect square, the result is also a perfect square. Not to mention they're a pair of the same numbers. So 16 times 35, 16 times 35 is still equal to the number 560. But now I know what my largest perfect square is, okay? If you just say you have a perfect square of 4 and that's all you factor out, 4 is a perfect square factor, but there's still going to be another one left. So you do this to figure out what's the largest perfect square factor I have. So instead of the square root of 560, I'm going to replace that with the square root of 16 times 35. I'm going to write 560 as factors. One of them will be a perfect square. What is the square root of 16? 4. Whenever I take the square root, I put the square root of the number outside of the radical, to the left of it. It's the coefficient. Is 35 a perfect square? Does it have any perfect square factors besides 1? No, its factors are 5 and 7, right? So 35 stays under the radical. Again, we spent a whole entire class period on simplifying radicals. That video is on where? Schoology. It could happen. Okay, so let's go back up to our problem. X equals positive or negative. I'm replacing the square root of 560 with 4 square root 35 over 14. Now, if 35 was a number that could be reduced with, like, say that was the square root of 28 over 14, I cannot reduce those because it would be square root of 28, not the number 28. They have different values. However, the 4 is not under the radical and the 14 is not under the radical. So if those can be reduced, I would need to do that. Is there a number that divides into 4 and 14? 2 divides into 4 how many times? 2 divides into 14 how many times? So that gives me positive or negative 2 times the square root of 35 over 7. Can I divide the 35 and the 7? No, because it's the square root of 35, not the number 35. They have different values. Notice on your paper it writes it as 2 separate answers. If it's a multiple choice, it's going to do the same. One of your answers is positive 2 times the square root of 35 divided by 7. Your other answer is negative 2 times the square root of 35 quantity divided by 7. You're going to write it out as 2 separate answers on the test if it's multiple choice. Yes, sir. Uh-huh. If you're going to reduce it. Like say you had a 5 in the top and a 14 in the bottom. Well, the only number that goes into 5 and 14 evenly is 1, and that won't change anything, so you would leave it alone. So if you only reduce if there is a number that divides into both evenly. Okay? Yeah, just reducing. Yep. Yeah, and so that's the same answers on your paper, right? Yeah. Whew, we got it right. Cool beans? Let's do 19. So we're still solving using the quadratic formula. Okay. 19. So when we're using a quadratic formula, just like factoring, we have to get it set equal to 0 and in standard form. So what would I do to get it set equal to 0? Subtract the 10x. So on the right side, 10x minus 10x is 0. On the left side, none of those terms are like terms, but we need to put them in standard form. What would my first term be? 3x squared, and then minus 10x minus 8. Very good. There's not a GCF, but even if there was, we would not factor it out. This is not factoring. All right, what is A equal to? What is B equal to? And what is C equal to? Negative 8. So we are using the quadratic formula. X equals negative B plus or minus square root B squared minus 4AC all over 2A. Yeah. Am I going to give you the quadratic formula on the test? No. Okay. So we don't ever plug anything in for X. That's what we're trying to find when using the quadratic formula. So I'm subtracting B. Think of it as the opposite of B. So what is the opposite of negative 10? Positive 10. Or you could say minus negative 10 and turn it into positive 10 on your next step. That's fine too. Plus or minus the square root of negative 10, quantity squared. Make sure you square the negative as well as the 10. Minus 4 times A is 3 times C is negative 8. All over 2 times A. So that would be 2 times 3. Then we simplify. X equals 10 plus or minus the square root of 100, and it's positive. Every time you square B, it's going to be positive because a negative squared is positive and a positive squared is positive. Please do the minus 4AC all at the same time, including the negative and everything. 96, positive 96? You're correct. No, you didn't. All over 6. So obviously we can simplify under that radical. X equals 10 plus or minus the square root of 196 all over 6. Now 196, always check to see if it's a perfect square, if it's a big number that you're not sure of. 196 square root, and we knew that, right? Because we made a list of perfect squares and 196 was one that I told you to memorize. So that's awesome when it's a perfect square because you don't have to worry about doing the factor tree and simplifying and all that stuff. 196 is a perfect square. So what is the square root of 196? 14. Gotta love it. I think you use your calculator. Good job. Okay, are you going to see this answer on your? No, this can be simplified. First of all, this is 2 answers. One of them takes the positive 14 into account. The other one takes the negative 14 into account. So I'm going to go ahead and write 2 separate equations. One will be 10 plus 14 quantity divided by 6. Not just the 14 is being divided by 6, the whole thing is. And the other one will be 10 minus 14 quantity divided by 6. Are you going to see this as your answer? No, because it can be simplified further. So what is 10 plus 14? And what is 24 divided by 6? Boom. Your other one, what's 10 minus 14? And what's negative 4 divided by 6? Oh, let's don't do a decimal. You're not going to see a decimal. We can reduce that though, right? What divides into 4 and into 6? 2. Okay, you know your numerator is going to be negative. That doesn't change. 2 divides into 4 how many times? And 2 divides into 6? So negative 2/3. That's how you reduce. Coolio? What's the problem? What are you confused about? Okay, so I still have to do completing the square. And I know there's a lot of problems on your review. So what I'm going to do is we'll just finish up me reviewing today. And then next class, I'll let you have the class period to work on it. So don't go home and do it for homework. Because if half of you are sitting here doing nothing next class and the other half are working, I don't want that. So we'll work on it next class and then have our test the following class period. Huh? Well, I still have to do completing the square. Like, I'm not finished. When I'm finished, yeah, the rest will be your responsibility. But I'm saying I'm going to give you next class to finish it, to work on it, and take any questions. Okay? Yeah. You're not going to see that answer on multiple choice. It's going to write it as reduced. Yes. Sure. I'm also going to post it on Schoology too. Yeah. Who? Oh yeah. Yeah, or you can send it to him, or you can tell him to look on Schoology, and I'll post this video on Schoology as well. Okay. Okay, 20 through 24, you have to solve by completing the square. That's what we learned last class. That's what only 5 of you turned in the homework for. Was I happy about that? Not at all. This review is going to be worth 200 points, just like all the reviews have been so far. Do you want to get a 0 out of 200 points? Probably not. I don't know. We haven't had that many assignments, so probably 400 points. It'll be equivalent to however many homework points we've had. It always is. 50%. Okay. Okay, completing the square. What I taught you last class. We don't get it set equal to 0 when we complete the square. That's only for factoring in the quadratic formula. For completing the square, we want to move all of the constants to the right side of the equation. So in this example, I would add 10 to both sides of the equation. So I get 6v squared minus 12v equals 15. If you were not here last class, this video is posted where? On Schoology. Your responsibility. Watch it. Take notes. If you just take the notes from the written notes, that's fine. But if you don't get it, you really need to watch the video to understand, okay? Y'all remember what the next step is? Very good. Divide each term by a if a is not 1. Because if a is 1, it won't change anything. So 6v squared divided by 6 is what? V squared. Negative 12v divided by 6 is negative 2v. And 15 does not divide by 6 evenly. We can reduce it though. What divides into 15 and 6? 3 divides into 15 5 times. So that's your numerator. 3 divides into 6 2 times. This is called completing the square. We are trying to get a perfect square trinomial on the left side, okay? So we have to figure out what would this constant have to be in order to create a perfect square trinomial. To do that, it's called completing the square. To complete the square, you take b, your new b, not your original b, divide it by 2, and square it. What is your new b? Not 2, negative 2. You just worked ahead of me. B is negative 2, right? Divide it by 2 and square it. What's negative 2 divided by 2? What's negative 1? Quantity squared, positive 1. So we have to add 1 to both sides of the equation, not just the left side, both sides, yes. Because I'm trying to come up, I need that third term to make a trinomial, but I want it to be a perfect square trinomial. So you don't have to have the space, but it kind of just reminds me, I'm looking for a number to go there. Or just added a 1. 1? 1 to nothing? Right, so it'll just, so plus 1 is what will go there. Because in standard form, I don't have any like terms, so it'd be v squared minus 2v plus 1. Yes? B is, you know, your A, your B, and your C, like when you're doing quadratic. Yeah, so A is 1, B is negative 2. We don't have a C yet, C is 0. So I get v squared minus 2v plus 1 equals, all right, 5/2 plus 1. It's 1 and 5/2, right? But we're not going to write 1 and 5/2. We're not writing a mixed number. We're going to write an improper fraction. You got to know how to do that. 2 times 1 is 2. 2 plus 5 is 7, and you leave the 2 as it is. 7/2. 2 times 1 is 2, plus 5, 2 plus 5 is 7, denominator stays the same. Okay? Y'all learn how to do this in like 3rd grade. Well, I'm saying that if we could figure it out in 3rd grade, we can probably figure it out again in high school. We are not. Yeah, I know there's a lot of excellent schools in Polk County. Back to the problem. We are going to factor. We have created a perfect square trinomial. That's a special type of trinomial. It's a special type of quadratic. If you don't remember the shortcut to factoring perfect square trinomials, then just do your teacher and divide and slide. But when you do, you're going to see that both of your factors are identical. Okay? So, shortcut is when you have a perfect square trinomial, make one set of parentheses and square it. You square it because when you have 2 identical factors, we can just write it as one factor, but we got to square it. The sign in between the terms is always the sign of b. C has to be positive to be a perfect square trinomial. It's always the sign of b. Y'all remember what your first term is? B. You remember what your last term is? The square root of the last term, square root of 1 is 1. Equals 7/2. Next step, do y'all remember the next step? No. Take the square root of both sides, and on the right side it said, don't forget, it's very important to take the positive and the negative square root of the right side. And when it's a fraction, I like to do the numerator and denominator by itself. And unfortunately, something's happening in this problem that did not happen in our notes, but that's okay, we need to know how to do it anyway. I'll get to it. On the left side, what is the square root of v minus 1 quantity squared? Just v minus 1. Taking the square root of something that's being squared, that is an inverse operation. It undoes itself. So basically, that gets rid of the exponent, the parentheses, and the radical sign. Just leaves you with v minus 1. Equals positive or negative. Okay, okay, okay. Is 7 a perfect square? Does it have any perfect square factors other than 1? Is 2 a perfect square? Does it have any perfect square factors other than 1? Okay, this is what did not happen in our notes, but you need to know how to do it anyway. Let's come over here to the side. You cannot leave a radical sign in the denominator. You hear me? You can't. Can't do it. Can't. I know can't, never, could, do nothing, but you cannot leave a radical in the denominator. And that's what my dad always says. Can't, never, could, do nothing. Are you from Tennessee? If you was, you probably would have heard it before. Okay. So to get rid of it, it's called rationalize the denominator. Rationalize the denominator. So hey guys, when you multiply by 1, does it change the meaning of the original number? No. Would you agree that 3 divided by 3 is the same thing as 1? What's 3 divided by 3? 1. They're equal, right? Looks different. If I said, I ate a whole pizza last night, and you say, I ate 3/3 of a pizza last night, did we eat different amounts? No. If your pizza's cut into 3s and you all ate all 3 pizzas, you ate the whole pizza. Just saying. So when you multiply by 1, it does not change the meaning of the number, correct? And you're telling me that 3 over 3 is the same thing as 1. That's true. 3 divided by 3 is 1. Well, is the square root of 2 divided by the square root of 2 equal to 1? Yeah, whenever you divide a number by itself, it always reduces to 1. 1 bazillion divided by 1 bazillion, is bazillion even a number? I don't know. What does that equal to? 1, okay? So to rationalize the denominator, you are going to multiply by a number that's equivalent to 1, but it doesn't look like 1. It's going to be a fraction. whatever the denominator is, you're going to make a fraction where the denominator, whatever the denominator is in the first fraction, that number is the new fraction what's in the top and the bottom, numerator and the denominator. Okay, so just watch. Like, why are we doing that? We're trying to get rid of the radical in the denominator. So when you multiply radicals, you multiply the coefficients together and you multiply the radicands together. Well, the coefficients on my numerator are both 1, so 1 times 1 is 1. We don't need to write that. The radicands, what's 7 times 2? 14, okay. The denominator, what do you think the square root of 2 times the square root of 2 is? 2, well, before we simplify it, square root of 4, okay, but you're right, what's the square root of 4? Did we just get rid of the denominator, the radical in the denominator? Yes. So 14, is 14 a perfect square? No. Does it have any perfect square factors other than 1? What? 2 is a perfect square? 7 is a perfect square? But the factors are 14 and 2, right? 14, or not 14 and 2. 7 and 2. 7's prime, 2's prime. They're not perfect squares. Is 14 a perfect square? Does it have any perfect square factors other than 1? No. So I can't simplify 14. If I could, I would. Can I divide the square root of 14 divided by 2? No, 14's under the radical. So it's not equal to the number 14. It's the square root of 14. Okay? So over here, this simplified to positive negative square root of 14 divided by 2. I know that was a lot, but it's going to happen. No, we just got rid of the radical in the denominator. You cannot leave a radical in the denominator. It's against the rules in the mathematical world. I rationalized by multiplying by 1. It just didn't look like 1, because if I multiplied by the number 1, I still have square root of 7 over square root of 2. I rationalized by a number that's equal to 1, but not 1. And it's always got to look at the denominator, make a new fraction, whatever is in the denominator, what you're trying to get rid of, make a new fraction, and that will be the numerator and the denominator. It will always get rid of the radical. What's the square root of 4? 2. So do you see when I multiply the square root of 2 by the square root of 2, I'm going to end up with just the number 2, right? The radical is going to go away. It's strategic. It's called rationalizing the denominator. If it was square root of 7 divided by the square root of 3, then I'd do square root of 3 divided by square root of 3. Because if I did square root of 2, it wouldn't get rid of it. So whatever the denominator is. So say I had the square root of 5 over the square root of 7. I would multiply by what? So square root of 7 over square root of 7, because that's going to give me the square root of 35 over 7. Square root of 49 is what it's going to be, and the square root of 49 is 7. Okay? 7 times 7 is 49. What's the square root of 49? 7. So whenever you multiply a radical by itself, the result is just that number without the radical sign, once you simplify. Yes? If you end up with a radical in the denominator, yes. No, the shortcut was when we factored the perfect square trinomial. I'm still not finished with the problem. I don't care. Okay, once we have gotten to this point, I need to make 2 separate problems. One is equal to the positive square root of 14 divided by 2, and the other one is equal to the negative square root of 14 divided by 2. So v minus 1 equals the positive, and I don't really have to write that, but sometimes y'all forget, and I don't want you to. The other side will be v minus 1 equals the negative square root of 14 divided by 2. Do not divide 14 and 2, because it's the square root of 14, which is a whole different number than the number 14. All right, then solve for v. So I'm going to add 1 to both sides. v equals 1 plus the square root of 14 divided by 2. That's one of your answers. Look on your paper. It doesn't have that answer. Y'all remember why? I taught you last class, told you you're not going to see this. This is correct. but you're not going to see it as an answer choice. Right, I got to make it so that they're two fractions with both the same denominator. If one's a whole number and one's a fraction, they're going to want you to write it as two fractions. So how could I write the number 1 as a fraction, but it has a denominator of 2? Very good. So I'm going to replace that with 2 divided by 2 plus the square root of 14 over 2. So that way they'll both have the same denominator, and I can write it as one big fraction with a denominator of 2, and then put my numerators on, together. So 2 plus the square root of 14. Same thing on the other equation. So that'll be v equals 1 minus the square root of 14 divided by 2. You already know I'll turn that into 2, right? And have 2 minus the square root of 14 quantity divided by 2. I just did it one less step because it's just like the one next to it, except for we were subtracting 14, square root of 14 instead of adding it. Whew, goodness. I know. It is what it is. I'm not finished. Don't put your stuff up. I'm giving you the whole next class to work on the rest of the assignment, okay? You're going to give me this class. I'm doing one more problem. Hey, that's one less you got to do. And it's more review for you, right? So we're not complaining, are we? Well, I hate to tell y'all, but we're not sitting here for 28 minutes. It sounded like there was some complaining. Well, you might want to study, okay? You might want to study. You know how I study math? Do you want me to tell you how I study math? Because kids always say, you can't study math. Yes, you can. You take your notes, okay? Cover up your whole problem with a piece of paper, not your hand. Write the problem on a separate sheet of paper. Work it out. See if you match up with the answers that you got when you took the notes from me, because you know that was correct. See if it matches up, and if it doesn't, look at it and figure out where you went wrong. Try another one. Do the same thing. You can totally study for math. Yeah, I'm sure if you redo this next class 2 days from now, you're probably not going to remember exactly how you did this problem. All right, just a guess, just a guess. Let's do number 5. Seems like it will be a little, I'm sorry, 21, not 5. I don't know where I got 5 from. There you go. Seems like you won't have any craziness going on with number 21. 5a squared, and I'll try not to give you one on your test where you have to rationalize. I'll try, but if it happens, I mean, you know how to do it now. Great, good job. All right, so I'm completing the square. When I complete the square, I don't want it set equal to 0 in standard form. I want to get my constants over on the right. So I'm going to subtract 24, very good. When you're factoring in quadratic formula, you want it set equal to 0. Completing the square, you don't. Okay? So I get 5a squared minus 20a, that cancels, negative 15. Now what? Not yet. Divide every term by a if a is not 1, and it's not, a is 5. So we get a squared minus 4a equals, negative 15 divided by 5 evenly. That's nice. We won't have a fraction there. What do you get? Negative 3. 15 divided by 5 is 3. So now we want to make a perfect square trinomial on the left side. That's why we're doing these steps. So we need a specific number for our new constant in order to make a perfect square trinomial. To figure out what that specific number is, you take b, divide it by 2, and don't forget to square it. So what's your new b? Not your original b, your new b. Not 4. No. Negative 4. The sign before, the sign to the left of the term goes with the term, okay? Always. What's negative 4 divided by 2? No. Negative 2. Quantity squared is what? 4. What do I do with that 4? Add it to both sides of the equation. If you just do one side, you just change the meaning of the problem. So a squared minus 4a plus 4 equals 1. Yep, negative 3 plus 4 is 1. We have created a perfect square trinomial. When you have a perfect square trinomial, there's a shortcut to factoring it. You can't factor everything this way. It only works for perfect square trinomials, okay? So the shortcut is make one set of parentheses. Don't forget to square it. What's your sign going to be? Sign. Negative is always the sign of B, never the sign of C. C is always going to be positive with the perfect square trinomial, okay? I mean, you might get lucky and it's positive, but it's always the sign of B. What's the first term? A, because it's the square root of the first term. What's the last term? 2, because it's the square root of the last term, okay? Square root. We're only looking at the left side of the equation. What? A little practice, maybe you might want to go back and watch that video. Okay, what do I do now? Square root of both sides, the same thing. So a minus 2 quantity squared, and remember, it's very important that you take the positive and negative square root of the right side. Because you got to have 2 answers. If you don't take the positive and negative, you're only going to end up with 1 answer. That's only half of the work, half of your answer. What is the square root of a minus 2 quantity squared? A minus 2 equals plus or minus. Hey, isn't 1 a perfect square? What's 1 times 1? So is 1 a perfect square? And what's the square root of 1? 1. Boom. We don't even have a radical to worry about anymore. So, no. Have I solved for A? 2 separate equations. One of them set equal to positive 1. The other one set equal to negative 1. Do not change the sign of the 2. That's not plus or minus 2. The plus or minus only goes with the 1. Okay? And I just solve them both separate. A equals 3. And A equals 1. That's both of the answers. 2 answers. Okay? Again, the rest you will have to complete on your own, but do you have to do it for homework? When are we going to do the rest of it? Next class. You already have the answers there. Do it next class. If you're here next class or you're not here next class, you still have to take the test on Tuesday. You say, well, I wasn't here the day we did it in class. You're still taking the test on Tuesday. You know about the test? Be ready for the test, regardless, okay?